sketch the function f of x is equal to 2x minus 6 divided by 2 minus x. We need first to find the horizontal asymptote. And how do you find the horizontal asymptote? Horizontal asymptote, if the degree of the numerator is equal to the degree of the denominator, meaning the highest power on top and the highest power down, they are the same. Simply get the number in front of the highest power on top, divide by the number in front of the highest power down, that is the -1, and that will give you the horizontal asymptote, which is -2 in this case. And then for the vertical asymptote, the vertical asymptote simply equate the denominator to 0, that is 2 minus x is equal to 0, and that is going to give us what? That is going to give us the x being equal to +2. So this is going to be it. That is what we are going to be able to have. Now, how do I sketch this function? So what I'm going to do is the function which is on top, I'm going to equate it to 0. We are going to find that x is going to give us a 3. If I equate what is on top to 0, the 2x minus 6 is equal to 0. And then we've already equated the denominator to 0, and we have found that x is equal to +2. I'll write a table of values. 2 is smaller than 3, so I'll put it like that. I'll put the factors which are equated to 0. I have got 2 minus x. I also have 2x minus 3. I have simply factorized out this one. Because these two are dividing, I'm also interested in the quotient of the signs that I'm going to get. So when I equated 2 minus x to 0, I found a 2. If I use anything above 2, any number above 2, for example, a 3, I put in this function, it is going to be negative. Above 2 is going to give me a positive value, for example, a 0. When I equated 2 times x minus 3 to 0, I found the 3. If I put any value of x greater than 3 in this function, which is the 2 times x minus 3, to give me positive, for example, a 4. Anything up below 3 is going to give me a negative. The quotient of signs, negative over positive, is negative, positive over, negative over negative, positive, negative over positive, negative. And then we can now put this on our graph. We have got the x values there, and then the y values there. So for this function, the horizontal asymptote is at -2. So -2, let's put it here. And then the vertical asymptote is at +2. That is the value of x. Let me put it here. Okay. Now I'm going to use the table to be able to sketch. We can see we also have a 3 here. So let me just put a 3 somewhere there. From -infinity to 2, all values of x smaller than 2, we can see the function is negative. Negative just means below the horizontal asymptote. So it's going to be below here. Okay. But we are supposed to be following this asymptote going down, and then also this asymptote going in this direction, meaning that this function would be something like this. We just connect these two values. Let me draw it much better. So that is how it's going to go. And then between 2 and 3, the function is positive, between 2 and 3. So from 3 here, if we are going like this, we're supposed to follow the asymptote. We can't cross the asymptote. And then from 3 to infinity, the function is negative. And this region is negative. Okay, it's below the x-axis. So like that. So this is going to be the sketch of this function. One value important to find is where the function is crossing or cutting the y-axis. And where it cuts the y-axis, x is equal to 0. So we put 0 here. We also put 0 here. We're going to have -6 over 2. This is -3. So the domain of this function is from the smallest value of x we can have is negative infinity up to 2, and then from 2 we are going all the way up to infinity. And then the range of this function, the smallest y value we can have is negative infinity going all the way up to negative 2, and then from negative 2 we are going all the way up to positive infinity up the function.